In this video, I'm going to be talking about systems of equations. Now, it's important to know that whenever we're trying to find the value of variables, and I don't mean just like in terms of another variable, we actually want a specific number for it, we have to follow the rule that's outlined in this corner here. Okay, and that's for every unknown variable, you must have one unique equation. Okay, so you can't just have a same equation twice or expressed in two different ways. It has to be a unique equation to solve it. Okay, so let's take a look at this one, for instance, like 2x minus y minus 1. You wouldn't be able to tell me what x or y was because they are both dependent on each other. So x depends on y and y depends on x. However, as soon as I set one of them, then I'd be able to find the other one. So if I said, for instance, x was equal to 0, okay, then I'd have 2 times 0 minus y minus 1 equals 0, and 0 minus y is equal to 1, and negative y is equal to 1, which would mean that y is equal to negative 1. Okay, and so right away, as soon as you set one variable, then the other variable can be found as well. But you can't do that unless you know what the other variable is. Okay, so there's a couple different ways we can solve them. So in this case, I have two different variables, and specifically in these examples, I'm going to be working with linear equations, so equations of straight lines. So here I have x minus y plus 2 is equal to 0, and 2x minus y minus 1 equals 0, and these are both in the general form. Okay, the first method I could use is method 1, okay, which is just graphing. Okay, so I could solve this graphically. Now, graphing is probably the worst way of solving this because it often requires you to make a guess about where these graphs are going to meet. Okay, now if these both represent the same type of situation, or the same situation, not the same type, but the exact same situation, okay, then wherever these two lines intersect is going to be the place where the x and y values meet. Okay, so in order to graph this, I'm going to need to express these in slope-intercept form. Well, I guess I don't have to, but this would be the easiest way to do that. Okay, so I'm just going to move them side to side here, so I can write here. Okay, in this case, what I would get is y is equal to 2x minus 1, and what I did is I just added y to both sides, so I said plus y, okay, and then I just flipped the equation to express it in the reverse order. So y is equal to 2x plus 1, and in this case I can do the same, add y to both sides, and I'd get y is equal to x plus 2. Okay, so I have two distinct equations here. Okay, now the intercept, I'll draw it in purple, is at negative 1. Okay, so there's my intercept. Okay, and the slope is 2, which means that for every 1 it goes across, so 2 over 1 is rise over run, so it goes up 2 and across 1. Okay, so that's a point there. Okay, and I can draw a line between these. Okay, so something like this, and it's important if you're doing this graphically to get these as close to being exact as you can. Okay, so that's about as close as I can get that. Alright, I'll draw the other line in blue. Okay, and so that was 2x minus 1. Let's do x plus 2. So the intercept here is 2. Oops. 2. Okay, accidentally erase those. I have to just draw this back again. Oh, never mind. Oh, and I will have to draw it back again. Just a sec. Okay, that's pretty close. Oh, that was a lot faster this time. Okay, I'll draw the other one in blue. So in this case, my intercept is plus 2. And my slope is 1, so it goes across 1 and over 1. Okay, and hopefully these intersect on the same area here. Okay. So in this case, what I can see is that they seem to intersect at this point. Okay, now I'll just draw this as a big green one. That's not very good. Brown one here. Okay, so it looks like they should intersect there. And we can just double check it. So this goes over 1, up 2, over 1, up 2. And so yes, it does go there. This goes up 1, over 1, up 1, over 1. So yeah, they both intersect there. And this is 1, 2, 3. So the point is 3, 1, 2, 3, 4, 5. 3, comma, 5. Okay, and what that means is that the value of x equals 3 and y equals 5 satisfies both equations. Okay, and let's just see. So if I said 5 is equal to 2 times 3 minus 1, 5 is equal to 6 minus 1, and 5 is equal to 5, we get a check mark for that. Okay, and then we check with the other one, and we have 5 is equal to 3 plus 2, and so that means 5 equals 5, and we get a check mark for that one too. Okay, basically this is what you do for every single one. Not graphically, but whenever you find the answer, you replace them in the answer into both equations, and if it satisfies the equation, that means that you got the answer correct. Okay, so that's how you solve these methods graphically. However, this doesn't always work very well, and the reason why is because these equations don't really, like this, we're kind of fortunate in this case because the equations meet at a nice intersection. However, if they didn't meet at an intersection, say met like somewhere where the cursor is like right now, or where the cursor is right now, it wouldn't be very easy to find out what that value was. And it could be like, you know, some weird fraction or some weird radical or something like that, and so it might be really difficult. Anyways, I'll show you another method here that would help us. Okay, the second method is called method 2, substitution. Substitution. Okay, now with substitution, what we do is, I'll just put this up here. Okay, so with substitution, what we do is we can express the one in terms of y and then replace it and substitute it in another equation. Okay, so we won't need this here. Okay, and here I have this y, this equation expressed as y. Okay, and I'm just going to get rid of this line in between. Okay, and so I have the equation from here, x minus y plus 2 is equal to 0. Okay, but I know what y is from this equation, so I can substitute it in. Okay, so what I can do is I can say x minus 2x minus 1 plus 2 is equal to 0. Okay, and this 2x minus 1 comes from here. Okay, so I have x minus 2x. Now this is where a lot of students would make mistakes. Okay, that this negative sign applies to everything in the brackets, so this becomes a positive one. A really common mistake is that students would keep this negative. Okay, plus 2 is equal to 0. Okay, and so I have x minus 2x is minus x, and plus 3 is equal to 0. So I have negative x is equal to negative 3, and x is equal to 3. Okay, and again, we found that the answer before was 3, 5. Okay, so the x is equal to 5. Now I could substitute again, but instead of doing that, what I will do is just do another sort of substitution. I'll say, go back to my original equation, x minus y plus 2 is equal to 0, and substitute the 3 back in. So 3 minus y plus 2 is equal to 0. Okay, and then I would get is y, by adding y to both sides. Okay, I would get 3 plus 2 is equal to y, and 5 is equal to y. And we found before that the answer was x equals 3 and y equals 5. Okay, so same thing. Okay, that's substitution. Okay, so with substitution, what we do, again, just to review, is we express one of the equations in terms of either x or y, and then we use that expression to substitute in the second equation, and that's how we solve it. Okay, so method 3 is one called elimination. Okay, now with elimination, what we're going to do is we're going to perform arithmetic directly on the equations. Now, a lot of people don't know that you can do that. Okay, in the same way that you can say like 5 plus 3 is equal to 8, or you could say 6 minus 2 is equal to 4, you can do the exact same thing with equations. Okay, so I'm going to take this equation, and I'll just place it over here. And then I'm going to take this equation and place it underneath it, and I'm going to line up the x's and y's. Okay. Now, what I have here is the same type of arithmetic as before. Okay, so what I can say then, now I have to decide if I'm going to add or subtract. And here what I have is the two y's are the same. Alright, so what I'm going to do is I'm going to subtract. Okay, so my goal in this in adding or subtracting is to try and eliminate one of these variables. Okay, and I can't really eliminate the x because the x is not the same. Okay, so there's no way I could really do that in this case, and I'll show you how to do it if it's not the same in just a moment. Okay, but the y's are the same, so I'm going to subtract them. Okay, so I got 2x minus x is just x. Now negative y minus negative y, so that's negative y plus y, is 0y. Okay, so plus 0y. So you can see the y has gone away. And then I got negative 1 minus 2 is equal to negative 3. And then 0 minus 0 is just 0. Okay, so then I end up with x minus 3 is equal to 0. And x is equal to 3. Okay, once again, after I found the x, what I would choose to do is substitution. So I would say 2 times 3, or starting with 2x minus y minus 1 equals 0. So 2 times 3 minus y minus 1 equals 0. So this would be 6 minus y minus 1 is equal to 0. And 5 is equal to y. Okay, and again I got x equals 3, y equals 5, which is the same answer we've been working towards all along. Okay, now a common question that gets asked to me is, well, what happens if you can't, like these don't add up? In this case, these are the same, so this works well. But what if it was the situation where we were trying to find the x, okay, and they don't? Well, what I could do is I can multiply this to make it equal. Okay, so I could multiply everything here by 2. So this would become a 2x. That's a terrible 2. 2x. That's just as bad. 2x. And then this would become a 2y. And this would become a 4. Okay, and then 0 times 2 is still 0. Okay, and then I just do the same thing. Now in this case I have 2x and 2x, so I'm going to choose to subtract them. Okay, so 2x minus 2x is 0x. Negative y minus negative 2y is equal to y. Okay, so it's just positive y. And then negative 1 minus 4 is negative 5 is equal to 0. So 0 minus 0 is 0. Okay, and I get y is equal to 5. As we can know from before, x equals 3, y equals 5. And then once I'm here, I could substitute again and substitute the 5 into one of the equations and find the x is equal to 3. Okay, and so that's really it for graphing, elimination, substitution for solving systems of equations. Okay, my next video will be on trying to solve some certain word problems. Really, it's a lot of just the same thing, but in word problems, what we're trying to do is, the difficult part is just going to be trying to set up these equations to begin with. Anyways, if you have any questions, then please drop me a comment or send me an email. If you do like the video, then please give me a thumbs up, and if you do like the channel, then please subscribe.